Hey guys, we're going to move on to lesson 5.5. So let me present my screen and we'll get started. Okay, so lesson 5.5, we're going to continue talking about triangle congruency. At the top, I'm just going to write a reminder of what we know so far as ways to prove triangles congruent. There's my pen. Let's do that line to scribble first. All right, so far, we know that if you have two triangles, I'll call this one ABC, and the second triangle DEF, or ETF, I should say. All right, if you have this angle congruent to this angle, this side congruent to this side, and this side congruent to this side, then we can say that triangle BAC is congruent to triangle DEF by side angle side. Because, oh, am I off the screen? I'll write that down below. By side angle side. All right, because you have a side congruent to side, another side congruent to another side, and the included angle congruent to the included angle. So side, angle, side, angle, side. SAS, okay? Today we're going to move on and learn a few different theorems that will help us continue to prove triangles are congruent. The first is known as side-side-side congruency. All right, and as you can probably guess, this theorem says that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. And remember, the name we named the triangles is super important. So they named it triangle ABC, so ABC, and then triangle DEF. So think about it as traveling along the side with a single tick mark, double tick mark, triple tick mark. So you have to do the same thing over here so that corresponding pieces match up. So if I changed it, let's say I named it CAB, right? How would you name the second triangle? So from C to A, and then A to B, and then close it up. So you're traveling along 3 tick marks, 1 tick mark, 2. So you want 3 tick marks, 1 tick mark, 2. You're going to name it FBE. D. I think I said the wrong letter. FDE. Okay. All right. Then we have another theorem. Oh, one other thing. Sorry, before we move on. If you're going to use side-side-side congruency theorem in a proof, you're still looking for your 3 stars, your 3 congruency statements, and those 3 congruency statements should all be congruency statements about 3 sides, which is how you know you're using side-side-side. All right, the next theorem we're going to talk about is called hypotenuse leg. So first off, what kind of triangles have a hypotenuse? The only kind of triangle that has a hypotenuse is a right triangle. So this theorem is only used for right triangles. But caution, just because a triangle is a right triangle doesn't necessarily mean that they're going to be congruent by HL. Okay, you can still use side-side-side or side angle side in right triangles. Okay, but hypotenuse leg only works for right triangles. So if the hypotenuse and a leg of one right triangle, so hypotenuse and leg of one right triangle, is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent by hypotenuse leg, okay? So be careful here too. Sometimes students want to say, oh, there's an angle, a side, and a side. Angle, side, and a side. Oh, if you're writing a bad word on your paper or typing a bad word on the computer, then you'll know you're making a mistake, okay? We do not have an angle side-side theorem or postulate. We also don't have a side-side angle. So whether you spell ASS or spell it backwards, SSA, it's not going to work, all right? So that's kind of a clue that you made a mistake. Now, if it's a right triangle, then you can use hypotenuse leg to indicate that the two triangles are congruent. Again, make sure you name the triangles so corresponding pieces match up. So I'm going to name it differently than how they named them, just as another example. You could name it triangle A, B, C, and then D, E, F. Or I can name it triangle A, C, B, and say that that's congruent to triangle D, F, E. So again, it is important the way you name the triangles, corresponding pieces have to match up. All right. So let's look at some extra practice problems. It says in exercises 1 through 4, decide whether the congruency statement is true, explain your reasoning. So we want to know, is triangle ABC congruent to triangle EDC? Okay, so look at the markings. You have a side congruent to a side, you have a side congruent to a side, and a side congruent to a side. So you can say, yes, triangle ABC is congruent to triangle EDC by side, side, side. Right now, I know they don't look very congruent, at least to my eyes, they don't. These are not necessarily always drawn to scale, okay, especially if I created the diagram myself. Sometimes I'm not the best at drawing to scale, but if they have the correct markings to prove that they're congruent, you can go ahead and say they're congruent. Something else I want to note for this problem especially, all right, do you see that you have isosceles triangles? Right? If you have two congruent legs, aren't the base angles congruent to each other? Two congruent legs, aren't the base angles congruent to each other? So once you put those markings in, then you could actually say that the triangles are congruent by side, angle, side. So I'm going to say or by side, angle, side. But if you wanted to use side, angle, side, let's say you're doing like a proof or something, you'd need to first state that they were isosceles triangles, state that the base angles were congruent in order to use side, angle, side. Okay, but that is an option as well. Right, let's go on to number 2. So we want to know, is triangle KGH congruent to triangle HJK? Well, I see that this side is marked congruent to that. This side is marked congruent to that. So if I was listing congruency statements, I have my 2 stars so far, right? I have that HG is congruent to KJ, that's 1 star. And I have that GK is congruent to HJ, that's my 2nd star, but I need 3 stars. Can I mark any angles congruent? Not enough information to mark any angles congruent as of yet. All right, but I can mark this side congruent to itself, right? I can say that HK is congruent to HK, and if I was doing a proof, the reasoning would be reflexive property. Now I have my 3 stars, my 3 markings. I can say that triangle KGH is congruent to triangle HJK by side, side, side. All right, let's keep on moving. The next problem, I actually think there's a typo. Let me fix the typo real fast. This, I don't think I ever fixed it. Nope. This is supposed to say Y, X, Z. So let's change that first. So is triangle UVW traveled along the 1 tick mark 3 and then 1 congruent to Y, X, Z. And you can say yes here, that triangle UVW is congruent to triangle YXZ, Y. Well, if I wanted to list it, I would have my 3 stars, my 3 congruency statements, because I have the 3 sides congruent to each other. So it's by side, side, side. And the last one on this page is triangle RST congruent to triangle RPQ. Well, looking at the markings, I have that this side RS, I'm going to list these this time, is congruent to this side RP. I have that this side TR is congruent to this side RQ. I have that ST is congruent to PQ. So I have my 3 stars, and they're all statements about the 3 sides. So I know that, triangle RST is congruent to triangle RPQ by side, side, side. Now you could mark these 2 angles congruent to each other, right? If we're doing a proof, you could say that angle SRT is congruent to angle PRQ, and that's because vertical angles are congruent. And then you could actually use side, angle, side. So, or by side, angle, side. Again, in order to use side, angle, side, you'd have to include this reflexive piece. You'd have to state the angles were congruent. All right. Let's see what else we're going to look at today. Okay, we're going to practice a proof or 2. I think we're just going to actually do number 5. We're not going to do proof number 6. So let me set this up, statements and reasons. Statements, reasons. All right. So the first is that B is the midpoint. I'm not going to have enough room for this. Give me 1 second. Let me just, since I'm not going to do this proof just for now, I'm going to delete that out of the way. There we go, to give me more room. All right, so B is the midpoint of CD. You're also given that AB is congruent to EB, and you're given that angle C and angle D are right angles. Okay, that's all given. That's a lot of information to be given. So let's make sure everything is marked on the diagram. Okay, if B is the midpoint of CD, what does that allow you to conclude? It's not marked on the diagram yet, which means we can mark it and we can write it. If B is in the middle of DC, that means that CB is congruent to BD. So CB is congruent to DB. Now, how did we know that? I read that this was the midpoint. That's the definition of midpoint. All right. Okay. And then you were given that this side is congruent to that side, and you're given that this angle is a right angle and that angle is a right angle. So far, I have 2 stars. I have a congruency statement there, and I have a congruency statement there. Okay. Now, typically, I say you need your 3 stars, your 3 congruency statements. However, there is one theorem that you actually only need 2 stars for, and it's that HL theorem. Okay. If I scroll back up for just a minute. Where is it? Hypotenuse leg. If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the triangles are congruent. So since you were told that you had a right angle, right, you know that those 2 triangles are right triangles. So we actually can, or you know what, we're going to state that the angles are congruent just for practice. So I'm trying to decide where to write because I'm out of room. I'm gonna have to pull it over here, guys. Sorry, I know it's not ideal, but let's continue our proof over here with statement 3. So because you know that C and D are right angles, that means that the measurement of angle C is equal to 90 and the measurement of angle D is equal to 90. And that is definition of right angles, right? If you're told you have a right angle, then you know that that means it equals 90 degrees. Now, if they're both equal to 90 degrees, that means that angle C is congruent to angle D. I just wanted to get the 3 stars, okay? Because all the other proofs we need the 3 stars. And that's based on definition of congruency. And then finally, you can say that triangle ABC is congruent to triangle EBD because of HL. The hypotenuse of one triangle is congruent to the hypotenuse of the other. The side of this triangle is congruent to the side of that triangle, and they are right triangles. All right. Okay, that was a little messier than what I would have hoped for. All right, so down below, this is more practice of what we already did earlier today. So I'm going to, for these last 6, I'm going to ask you to try them on your own. Okay, so pause the video, try them on your own, and then come back here, and I'm just going to quickly write down the answers. All right, so pause me, try them on your own, and then come back here. All right, so hopefully you gave them a shot on your own. The first one is triangle HKJ is congruent to triangle LKJ by SSS. The reflexive piece here, you can mark that side congruent to itself. For number 8, you can say the triangle JKM is congruent to triangle NKL by HL. Number 9, you can say that triangle ZWY is congruent to triangle XWY by side, side, side. For number 10, you can say that triangle ART is congruent to triangle ARG by side angle side. Again, the reflexive piece there. And notice for this one, even though it's a right triangle, we're not using HL. Oh, I should have marked the reflexive piece up here too. Okay. Number 11, you can say that triangle ART is congruent to triangle ARG by side, 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 or by side angle side. If you're wondering how I got side angle side, it's a little bit tricky to see, but if you focus on the big triangle, do you see triangle TAG? Just focus on that one triangle. What kind of triangle is it? It's isosceles. This leg is congruent to this one, so this angle is congruent to that one. All right, so once you mark those angles congruent, you can say that the triangle is congruent by side angle side. Okay, side angle side. All right. And the last one, you can say that triangle DBA is congruent to triangle DBC by side angle side. And the reflexive piece can be marked. All right, so if you're like, how am I supposed to check my triangle names because I named it differently than you? Depending on how you name the first triangle, your second triangle does need to be named consistently. So for number 8 example, let's say you named the first triangle MKJ, then your second one, just do the same order of the letter. It should be LKN. Or if you name the first one KJM, then your second one should be KNL. So you can check that you named them correctly, even if you didn't name them the same way I did. Okay. All right, guys, that is going to be it for lesson 5.5. All right, so I'll see you back here for the next one. Bye.